Here we look at absolute values. So the absolute value of a number a is denoted by this symbol, the absolute value of a, and it's equal to the distance of the point A on the number line from the origin. So there are two possibilities. If a is greater than 0, that distance is a itself. But if a is less than 0, then that distance is negative a. So for example, suppose a is 2, then the distance of 2 from the origin is 2. But on the other hand, if a is negative 2, the distance from the origin is still 2, and that's equal to negative 2. So to describe this symbol, we need to explore two cases, and so we need two lines in its description. The absolute value of a, if a is greater than or equal to 0, that's equal to a, and it's equal to negative a if a is less than 0. And similarly, when we're calculating, we need to consider both possible cases. We need to figure out which case we're looking at in order to calculate. So for example, the absolute value of 2, well, I have to check out, is 2 positive or negative? 2 is positive, so the directions say that the absolute value of 2 is 2 itself. What about the absolute value of negative 10? Well, I have to read the directions. Negative 10 is less than 0, so therefore the absolute value of negative 10 is negative 10, and that's just 10. And of course, after a bit, you'll leave out this part, because you'll realize you're just making this number positive. The absolute value of 5 minus 9, well, first of all, I do the arithmetic. That's the absolute value of minus 4. And now I check out, is minus 4 positive or negative? Minus 4 is less than 0, so the directions tell me that the absolute value of negative 4 is negative 4, which is 4. And now the absolute value of 9 minus 5 is equal to, first I do the arithmetic, it's the absolute value of 4. 4 is greater than 0, so the absolute value of 4 is 4. Notice that we have the absolute value of 5 minus 9 is equal to the absolute value of 9 minus 5, and in general, we have the absolute value of a minus b is equal to the absolute value of b minus a, as you'll see below. Now, if we think about a few properties of this absolute value, it makes calculation easier, most especially when we get to dealing with variables which are unknown. These rules of calculating with the absolute value become very important, because we have to know when we can drop negatives from calculations, when we can or the fact that we can actually multiply absolute values to get the absolute value of the product, and so on, or break up the absolute value of a quotient into the quotient of the absolute values. These are very important properties of the absolute value, and they'll make a lot more sense when we're calculating with functions. The first thing to remember is that you always get a positive number when you take an absolute value. So no matter what a is, the product of taking the absolute value, or the output, is always a positive number. Secondly, we have the absolute value of a is always equal to the absolute value of minus a. And that makes sense if you think about the numbers in the number line. Suppose you have 2 over here, the distance of 2 from the origin must be the same, by symmetry, as the distance of its negative from the origin on the other side. More importantly, it gives us a rule like this one. if I have two different numbers, x and y, the absolute value of x minus y is the same as the absolute value of the negative of that. And of course, when I take the negative of this, I can distribute that negative, and that's the absolute value of y minus x. And again, we'll see also why this is important in our distance calculations, or why it makes physical sense in our distance calculations below. Another rule, which is extremely useful, is that the absolute value of a times b is equal to the absolute value of a times the absolute value of b. And we can actually prove this by considering all possible cases. Here's a very concrete example. Suppose I take the absolute value of minus 10 times 2. So that's equal to the absolute value of minus 20. And according to our absolute value functions, minus 20 is negative. So this is minus 20, which is equal to 20. On the other hand, if I were to break up these absolute values into the absolute value of minus 10 times the absolute value of 2, on the right-hand side I would get the absolute value of minus 10 is 10 times the absolute value of 2, which is 2, which is 20. Now in this case, both calculations are very easy, but in the case where we will deal with abstract variables later on, we'll be looking at things like the absolute value of x minus 2 times x cubed, and we'll be able to say that that's the absolute value of x minus 2 times the absolute value of x cubed, etc., in our calculations. So this becomes very important when you're dealing with abstract variables. And of course, a similar rule says that the absolute value of a quotient is the quotient of the absolute values. So once again, this makes calculation very easy. To verify this, one would have to think through all possible cases, when a is positive and b is positive, when one is negative, and when both are negative. And it's relatively easy to prove, but a little tedious. Let's do an example, minus 20 over 2. The absolute value of that is equal to the absolute value of minus 10, which is equal to 10. And on the other hand, I could break this up into the absolute value of minus 20 over the absolute value of 2, and that's equal to 20 over 2, which is also equal to 10. That's just a simple example of why it works there, and it's certainly not a proof. To really prove it, one would need to consider all possible cases. And again, we're going to use this perhaps later on, something like this. You might be thinking about the absolute value of x times x minus 2 over x cubed, and you could then break that up into the absolute value of x times the absolute value of x minus 2 over the absolute value of x cubed, etc., etc. So that will certainly crop up in calculations with abstract variables and functions later on. Let's look at this example with numbers. The absolute value of 7 minus 10 over 21. How would I calculate this? Well, first I do the arithmetic here. It's the absolute value of minus 3 over 21. And now I can break it up. The absolute value of the quotient is the quotient of the absolute values. Absolute value of negative 3 is 3 over, 21, and so that's equal to 1 over 7. Second one's perhaps a little more confusing because it has a lot of absolute values, and the thing here is to work on the simplest parts first and work your way out from inside to out. So the absolute value of minus 2, so we take everything step by step. The absolute value of minus 2 I can calculate immediately. That's 2 minus the absolute value of minus 4 can be calculated immediately. And now I do the arithmetic here. It's the absolute value of minus 2. And now I'm all set. This is actually equal to 2. Lastly, let me point out the relationship between the absolute value and the distance between 2 points. So we have the distance between 2 points A and B on the number line is either B minus A or A minus B, depending on whether B is larger than A or not. So if A is larger than B, then that distance is A minus B. So in this case, the distance between A and B is a positive number, and it's equal to B minus A. And in this case, the distance between A and B is A minus B, which is equal to negative B minus A. And it's a positive number, and this one's a positive number. So we can describe this situation simply by giving a single formula, because that's exactly what the absolute value does. It tells us that the distance between A and B is B minus A if B minus A is positive, and it's A minus B, or minus B minus A, if B minus A is negative. So that distance is the absolute value of B minus A, so we can describe it in a single formula. Now, we must be a little careful when using this, because let's consider this case, the distance from minus 2 to 4 on the number line. This is our A, this is our B, and that distance I claim is the absolute value of 4 minus, and I must be careful here, this is minus minus 2. And that's equal to the absolute value of 4 plus 2, which is equal to the absolute value of 6, which is 6. And you can check this out here. If you draw a number line, you have 4 is over here, this distance is 4, and negative 2 is here, and this distance is 2. So the total distance is 6 here. And if B is less than A, let me do one more example. If B were less than A, suppose I want to find the distance say the number minus 5 and minus 10 on the number line. And so let's call this A and this B. So I want the distance between these 2 points on the number line. Well, it's just going to be the absolute value of B minus A, which is minus 10 minus minus 5. I think we all know the answer should be 5 here when we're finished. So I do this step by step. That's the absolute value of minus 10. Minus by minus gives me a plus. And that's the absolute value of minus 5. And that's equal to 5. And again, what's happening here is the following. I have minus 5 here, minus 10 here, and there's 5 units between them.